Let's think about some surfaces here. That are given in spherical coordinates. If we have rho equals 5, well, this is one of the good things about having spherical coordinates. Rho equals 5, if you think about it, means we square both sides. We have rho squared equals 25, and rho squared equals x squared plus y squared plus z squared. The equation rho equals 5 is synonymous with x squared plus y squared plus z squared equals 25, which we know happens to be a sphere of radius 5, centered at the origin. Okay, so rho equals 5 is a nice, neat equation for describing a sphere. Rho equals any constant would be a sphere centered at the origin at that radius. All right. Also, like we said before, spherical coordinates are good for spheres, and they're also good here for this one. This is phi equals pi over 3, so that means we're talking about all the points with the angle phi equals pi over 3. Well, that's the angle with the z-axis, and so we're talking about all of these points where we have an angle of pi over 3 from the z-axis. All right, and so if you think about all those points where we've got that angle being pi over 3, so if we go around here with all those angles, same pi over 3, so rotate out that way and then this way, and so we get what we wind up getting is a cone, because yeah, you can just keep those going, and it doesn't have to be necessarily that long. And so you get just get a nice cone shape, infilly going infilly out there. So yeah, phi equals pi over 3, that's the cone above the xy plane. With the angle being pi over 3. If we change that to pi over 4, then it's going to be slightly narrower, I guess, or make it bigger than pi over 3. Yeah, so you can make your cone as wide or as narrow as you want. Now, how would we get it? Let me ask you this: how would we get a cone that's below the xy plane in this orientation of our coordinate system anyway? Well, if we want a cone below the xy plane, then you think about it, I need this angle here to be where then our go further there. So we've got to go past the xy plane to make it below, like here. So yeah, we're going to have to, how would we get one like that? Well, to go past the xy plane would be at pi over 2, and so we're going to have to go beyond pi over 2. So phi equals c, where c is somewhere between pi over 2 and pi. That's how you could put this. That's how you get. So you're going to go to the xy plane and then just go beyond it. And so phi phi equals something between pi over 2 and pi would give you a cone below the xy plane, upside down in our normal orientation there. Okay. All right, so let's also here, a couple other things with spherical. So yeah, cones and spheres, very good to write in spherical coordinates. Easy to write. All right, so just real quick, convert to spherical these equations. X squared plus y squared equals 4. Well, first of all, we might, instead of going to spherical here, we might change it to a simpler form that we know. We know that x squared plus y squared equals r squared, so this is r squared equals 4. And since r has to be also greater than 0, we would know that r here would equal 2. And we know from our original drawing there that r, because of the right triangle that we get in spherical coordinates, where this is our kind of our angled this is r, and this is phi, so r is equal to rho sine of phi that gives us a little conversion there. So change this to r squared, which we can square root to get to r, and r is rho sine phi because of the right triangle we know these make. So yeah, there you go. In spherical terms, x squared plus y squared equals 4. Now, what do we know about x squared plus y squared equals 4? Well, x squared plus y squared in the xy plane is just a circle, and so if we extend that to 3 dimensions, that's a cylinder. So it's a cylinder radius 4, and so one other way you could look at it is this in spherical coordinates is a cylinder of radius 2. Probably not quite as easy to recognize, but that's what it is in spherical, cylinder of radius 2. Okay. What about x squared plus y squared plus z squared plus 2z equals 0? What would that look like in spherical coordinates? Well, again, you're looking for these things. X squared plus y squared plus z squared, we know that's rho squared, which is spherical. And then the only other thing we need to convert is the z. Well, we know z is rho cosine phi. This is actually maybe an easier one than the first one. So in spherical coordinates, that would be the equation of that, which that's going to be a sphere shifted a little bit.